Hi guys, Shouvik and welcome back to our YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have So today we have this count and say. Although it's tagged as a medium, but I feel it's a kind of easy questions altogether because only kind of brute I am able to think of, and I'm pretty sure it is the only solutions for this. So on the question, they have given a count and say sequence is a sequence of digit strings defined by the recursive formula. So they have defined a recursive formula while count and say of 1 means 1 and count of say of n is the running length encoding of count and say of n minus 1. Now what is the running length encoding? So that they have discussed here. So RLE or round length encoding is a string compression method that works by replacing the consecutive identical characters repeated 2 or more times with the concatenations and the number of marking the count of the character length of the run. So if you are not able to understand, don't be worried. So they have given an example also. For that we will definitely going to get off this. So let's suppose we have the string of this. Now if we write the RLE versions of it, so how many repeated same consecutive elements we have? So for 3 we have 2. So for 3, how many 3 consecutive we have? We have 2 threes. So replace this both 3 with first value to its count. How many consecutive? 3, 2, 3. And what is the element? What is the character? It's 3. It's 3. And post that. What is the consecutive elements after that? 2s. How many 2s we have? 3 2s. So 2 2 2 is going to be replaced with 3 2. 3 2. 3 is the count and the element is 2. Now replace 5 with 1 5. How many 5 we have? We have 1 5. So replace. So first is the count and then is the character. 1 is the count of 5 and then is the character. After that we have to replace this 1. So to replace this 1, we have single 1, the count of 1 is 1 and the character is also 1. Thus the compressed string becomes this. After this, the compressed string becomes this one. Very straightforward. Now suppose that given a positive integers n, return the nth elements of the count and say sequence. We have to return the nth elements. I think the question is very easy, very straightforward, but they have given a follow-up. I basically took the follow-up versions of solving it, like iterative versions. So maybe like they think the iterative versions is a kind of difficult, but I personally feel not so. Like any recursive or iterative is kind of same things. So exactly what they have asked to do, so I have done the exact same things on the code. I will just quickly go a little bit whiteboarding, not on very deep, but yeah, like you will get the gist. Like, so here you can see on the example test case n is 4. So initially they have asked for count say of 1 is 1, and post that you can do the operations. How many on count and say 2, how many 1 we have? We have single 1. What is the count of 1? Is single 1. And what is the element? 1. Post that we have this 1 1. For 1 1, how many 1 we have? 2 1s. And what is the element? 1. Now for 2 1, how many 2 is there? 1 2. So we first write the count of its 1 2 and post that we have written the elements. After that we have only single 1, then count of 1 and the element. Like this way you can do the brute. You will get your answer. So I think you guys got the gist, but if not, then I will going to, like, on very high levels, the exact same things I will going to explain on the whiteboarding also. If so let's suppose we have a characters of A B C D D E F. So if you have the strings, then just of its next versions, you have to basically think of how many consecutive characters you got. So we have two consecutive A's. So first write the count, then the element. Post that how many B's? 1 and then the character. Post that how many C's? 1 C character. How many D's? 2 D's character. How many E's? 1 E character. How many F? 1 F character. So that is the very next versions of it. Post that you can do the same things to it. Like, although A B C D are also, I think, the numeric, so you are going to get that only. So because we are starting n equals to 1, so basically this A B C D are also going to be numeric only. Let's suppose is this 1 is kind of 3, this B is 4, and this C is 7, this D is, let's suppose, 5, this E is 9, and this F is, let's suppose, 6. So the resultant string is after this 2 3 1 4 1 7 2 5 1, what is this, 9 and 1 6. So if you have these things, so then what you can do? How many 2s? 1 2. How many 3s? 1 3. How many 4? 1 1 1 1. 4 for 4 1 4. For 1, 1, 1. For 7, 1, 7. For 2, 1, 2. For 5, 1, 5. For 1, 1, 1. For 9, 1, 9. For 1, again there is a 1. That is again 1, 9. Then again 1, 6. So like this way it will go. It will grow. So for every steps it is at max can grow to the double. Grow to the double. So initially we have start to 1. Then maybe it can grow to 2. Then 4. Then it can grow to 8, like this way. So at max it can grow to 2 raised to the power 30, like this way. You can see like every n it is going to get of its double. So how much is 2 raised to the power 30? So if we can find, I think it's quite big value, 2 raised to the power 30 value. Two raised to the power 30 is kind of a very big value, but very standard mathematics, by very standard mathematics we can prove it, or no mathematics altogether. Just by seeing it we can see, like for these steps when it is grow to 1 1 1, it's doubled. But on next steps you can see it is not going to double. It's exactly on the same place, or it can shrink also, because if you have at any particular points, the characters are something like this 1 1 1. Then 2, then it can shrink, na? It can shrink, na? So we have 3 count of 1 and we have 1 count of 2. So from 1 2 3 4, or let's suppose if there is more 1, then 4 1 1 2 3 4 5 2. Now the length is, here the length is 5, here the length is 4. So it's altogether shrink. It's altogether shrink also. So by that only it's very intuitive that it is not going to grow at as big as like 2 to the power n. It's not going to gets doubled on every steps. It's not. It's absolutely not. And you can prove also that these things, like what we have at like, as we started from 1, so when it is going to be just 2 1s are going to be consecutive, then it is going to be 2 1. And at max when there are 3 consecutive ones, it becomes 2 3 1. So like this way it is never going to grow. It's never going to grow more than like a particular limit. So on that I personally feel it's very very intuitive. There is no standard mathematics, but by mathematics we can show it's grow to 2 raised to the power 30. Again, by mathematical intuitions we can say it's not grown as big as that. I personally feel to explain this particular problems is kind of difficult, why it is not going to grow as big as like 2 raised to the power 30. But you can first I will going to giving you iterations of the code, then I will give you the gist why by like code guidance or code like on your own test cases you can print the logs. By log you can you can prove that it is not going to grow as 2 raised to the power 30. But by mathematical inductions we can say like it is not going to get doubled on every row. So on code I did exactly the same things. First let's understand the codes, the brute that we just discussed on the or whatever is in the problem statement they have provided. I written the exact same code, but yeah, I will give how far this n can grow. I will obviously give a like solid conclusions of the final time complexity. Yeah, I will give you a solid punch on the final time complexity definitely. But first, try to understand the code. I think it's pretty tedious also. So I am running a loop. I initialize my answer to 1, and I am running my I to 2 to n plus 1, because I am starting my, I have already considered because for 1 they have already told that it is going to be, our answer is going to be start with 1. So I did sims, and I am running from 2 to n plus 1. And nn is the length of the current answer, and I choose the how many count of consecutive elements till now we have encountered, and what is the characters we are considering, because for every non-match we have to know the what is the characters count we till now encounter, right? So that's the reason I choose the characters, because for initially my count is 1, because we have a single 1, and what is the characters is answer of 0, that is of 1 also. And I have choose a updated answer, and I am going to append to my updated answer every time. And how I am doing to update my answer? Standard things. I will be going to run a loop for the last answer, whatever the answer we have at, because for every iterations, which is for our source of truth is the last computed string. Our source of truth is the last computed string. So our last computed string is answer. So what is the length of it? It's nn. I have stored, and I am iterating from 1 to n. And if there is a mismatch, if answer of j is not equals to answer of j minus 1, if just by checking the consecutive, if there is a mismatch, then I have updated my answer first with the count, string versions of the count, and then the characters, and I am resetting my count to 1, and my characters is also going to be reset to answer of j, because from that we are going to start a very fresh consecutive count. So that's the reasons my counter is, what is the reset part? for a counter, because the very first initializations, what's the value we put, we have to do the exact same thing. So it is the count of 1, and the character is answer of 0 here, and here is answer of j. Very straightforward. And if that is not a mismatch case, then we can consider it is a match case. Then we are increasing our count. And finally also, like when we are iterating at very next, so here you can see, like when we are this like 1 1 1 we are considering, so our count has 2 and our character is 1, so that is not going to be last mismatch case. It is not going to land on this particular if block, so our updated answer is not going to be updated. So at very last also, what is the count value we have, we have just append this to my answer, and finally the character also. And finally for next go, my answer is going to be my updated answer. My answer is going to be my updated answer. That's it, right? And finally we are going to return the answer. Now I am going to, before discuss the time complexity, I will just by console log I am going to give you like how far it can grow. So if we can print the length of the answer, because that's exactly this for loop is going to be executed, right? This for loop is going to be executed. So what is the length this for loop is going to be executed, that we have to be very very cautious. So on that our time is going to be rely on, and in we know it is going to be grow as big of 30. So now if we can do a print of length of answer, and I think I have very big test cases set all together. So if I can run it for this, for n equals to 30, you can see it can grow as big as 4462, that is 4062 only, 4462 only. So but we are expecting like 2 raised to the power 30, but by intuitions we are knowing it's not going to grow as big of 2 raised to the power 30, but we don't have a solid proof. Now I think we have a solid proof. It can't grow, man. It can't grow because it's when we have consecutive elements, it's grow to the shrinking phase. It's moved to the shrinking phase. It's not on the growing phase. It's moving to the shrinking phase altogether. So that's the reasons. Basically, it's not going to grow as big as like 2 raised to the power 30. Yeah, that's the mathematical intuitions behind this. The reasons it is not going to grow as big as like 2 raised to the power 30, and it is the proof, and this is the proof for sale. So yeah, guys. So that I personally feels the most optimal time and space complexity for these particular questions. And if we can just now quickly discuss the time complexity. So on time part, it is, so this for loop is going to be iterate for big of 30 for sure, and this not 30, it is 29 obviously, yeah, because we are iterating from 2 to n plus 1, and this for loop we have proved it can grow as big as like 4462 max, only this. And but there is one more, we are updating this answer. So here, like we are copying our answer to update of answer, we are going to copy to our answer. So that is also going to be a, if it is a not a pointer change, some language it's a pointer change, your answer pointer answer memory locations is going to point to updated answer. If that is the case, like Python and other Java language, it is the case. But if it is not, then it is going to be take another big of 4462 here also. But for our case, it is not. So yeah, guys. So if I can put it in a calculator, how it is 29 into 4462, 29 into 4462 as big as 129. We can consider 1.3 into 10 raised to the power 5. Yes, we can write it. So we can write it as 1.3 into 10 to the power 5. Yes. So that is the like most largest time complexity for this particular questions. I think it's very under boundary altogether. And on space part, we are very good. We are using any space, man? Count characters we are using, and yes, we are using updated answer which can grow as big of 4462. So yeah, we are using a space of 4462 also. Yeah, so that's, I personally feel is the most optimal solutions, time and space complexity, and there is only brute is like the best solutions, because the reasons we have proved also. We are able to see a intuitions, but we are not able to prove. But like console log or like print, we are going to system.out, we are able to print prove it. But on intuitions also, it's very difficult to prove, but on intuitions we are very sure. It's not going to get doubled on every iterations, because when we have a large consecutive, it's growing, it's going to get on the shrinking phase also. And here also, like you can see that we have only characters 1 2 3 only, right? As for the very big n equals to 30 only, but it can grow to as big as 4462. Here you can see we have only characters 1 2 3 only. So that means no characters are going to repeat it more than 3 times also. So if every characters are going to repeat 3 times, like 3 times also, so 30 into 3, like every times the character is going to get like three times of its consecutive, then also it can grow kind of like 30 into 30, like 900, but some more because we have the growing phase also. When we have a single one, on very next it can be written as 1 2. So here you can see, like if there is a single characters altogether present, so here you can see, so this 2 is going to be on next iterations, it can become 1 2, because it has a count 1 and it has the character is 2 1 2. So it can grow kind of like 3 times, not more than that, and its growing phase is very limited. It's not going to get doubled on every time. So yeah guys, so that's the mathematical or let's suppose a personal intuitions people should have to like prove it. I personally feel just log and prove on the interview, that is the most like identical way to or the best way to prove it. But yeah, like on mathematical part it's quite challenging, but you guys are able to get the gist while you are going to iterate like couple of test cases you can write and you can get the gist. So that's it guys, that's it for the most optimal solutions for this particular question. And if you guys are able to understand, I guess you guys is already aware of and you guys are already doing, so please do subscribe to our channel, and please share the videos who are basically preparing for the good top product based companies and also brush upping their DSS skills. Please share the videos with your friends so that they can also get the most of it, and please turn on the notifications when we are going to live with our next video. So that's it guys, that's it for today. Let's meet tomorrow with another beautiful video. Bye guys, bye.